Okay, so we're going to back up a little bit and look at how do we find the rate of change from a graph. So to be very specific about how we're going to do that from a graph. So the very first thing you have to do is that you have to find points or an ordered pair. So points are anywhere where our line, let me highlight our line real quick, goes through the grid at corners. So if we're looking at, like this point here, okay, that's not going through a corner. The graphed function is going through just a single side of the rectangle. However, if we move over a little bit, we can see that our graphed function is going through a corner. It's going through 4 corners of the rectangles. So that would be a point, or a point that we would want to use, an integer point. And then if we keep going, we see this one doesn't work, but this one does. So I'm going to go ahead and label all the good or integer points that I see. So for example, this first one we saw, that would be a good point. Over here, this would be a good point. This would be a good point. This would be a good point. Okay, so, and you should already start to see that there's a pattern as where those points appear, where those easily countable points appear. So that's the first thing we're going to do. The next thing we're going to do is we're going to find the rise divided by the run. Okay, so once I look at, I'm going to switch to blue here. Once I have my points, I can pick any 2 of those. So I can pick this one and this one, or this one and this. It doesn't matter. Just pick any 2. For funsies, I'm going to pick this first one and this last one we have noted. So by the rise, I mean how far do I have to climb up to get on the same level as this point? So I have to climb up 1, 2, 3. And then I have to go over 1, 2, 3, 4, 5, 6 spaces. Okay, so we might be tempted to say that my rise over my run is 3 over 6. However, I've really got to pay attention to the axis. So if we look at our x-axis, or sorry, our y-axis here, I see that it's actually going up by tens. So when I go up by 30 or by 3 right here, I'm actually going up by 30. And then to make that a little more difficult, I see that it's actually in thousands. So when I say plus 3, I'm actually going up $30,000. So my rise in this case is going to be $30,000. So now let's look at my run. So I said that my run was going over 6. But if we look again at my x-axis, we're going up by tens here. So when I say I'm going up by 6, when I say I'm going over by 6, I'm actually going over by 60. So my run is actually going to be 60. So now I can go ahead and reduce that fraction. So I'm going to have 30,000 divided by 60. Remember, when we're reducing by tens, we can kind of cross out that any zeros they have in common. So now I've got 3,000 divided by 6. I'm going to do some quick mental math. I know that 30 divided by 6 is 5. And I've got 2 extra zeros. So I know that my slope, or my rise over run, is actually going to be 500 when I reduce that. So if we think about what that means in terms of the problem, so my rise is 500 for every 1. So that means that for each student, the school is getting $500 in addition. So we're looking at that previous problem in addition to that $100,000 that they get. But my slope, or my rise over my run, would be 500 over 1, or just $500 when it reduces. Okay, so now we're going to look at a graph that's a little bit more straightforward. And we're going to look a little bit more at how to use the slope or the rate of change once we found it. So remember, our first step is still going to be finding our points. Okay, and I would say just find as many as you can. So we want to make sure that they cross at corners. So I see one here, I see another one here, and I see another one here. Okay, that doesn't mean that's where my line ends. It just means that that's all that they gave me. So now remember, my next step is that I'm going to find the rise divided by the run. Another way you might see this is the change in y divided by the change in x. Okay, so let's look at it in terms of change in y over change in x. So if I'm going to use these points this time. Let me go ahead and label those points as well. So the first point I colored in, whoopsies, I want it to be blue, has an x value of -4 and a y value of 2. So that's going to be -4, 2. And then my second point that I chose to use has a y value of, an x value of 0 and a y value of -1. So that point is 0, -1. All right, so let's look at this as the change in y over the change in x. So my first y value is at 2. My second y value is at -1. So we're looking at what's that vertical distance from this point to this point. So I would go down 1, 2, 3. And notice that the difference between 2 and -1 is also -3. So my rise is -3 because I'm going down. My run, so the distance between my x values, is going to be 1, 2, 3, 4. So my run is going to be 4. So my rise over my run, or my slope, is going to be -3 because that's the change in my y values over +4. Okay, and if you can reduce the fraction, you do. Now let's think about what we can do to use that. So we can test that by now going from this second point to this bottom point down here. Let's see if it works. If I've done this correctly, I should be able 1, 2, 3, and over 1, 2, 3, 4. And that works. So that means my slope works. Now if I want to extend this line, I just keep going. I go down 1, 2, 3, and over 1, 2, 3, 4. I can put a dot there, and I know that my line's going to go through that point. I can also go the other way. Let's go back up to the top right here. Okay, so now I'm looking right here. And I want to extend my line the other way. Well, when I was going down, I had to go down 3 and over 4. But now I'm kind of going in the opposite direction. So instead of going down 3, I'm now going to go up 3. So 1, 2, 3. And I'm going to go to the left 4. 1, 2, 3, 4. Okay, so if you go in an opposite direction, you just kind of reverse your rise over your run to finish connecting your line. All right, and last but not least, let's put this all together. So we have this little chunk of a line. Remember, our first thing we're gonna do is find some points. So I'm gonna have you go ahead and take a moment to find your points. Label as many as you can. And what I see a point here. I see a point here, here. So we've got a lot of points on this graph. All right, so you should have several points labeled. And remember, now you're just going to pick 2, and you're going to find the rise over the run. So what I'd like y'all to do is go ahead and identify which 2 points you're going to use, and then identify that rise over the run. So I'm going to use these 2 points up here because to me they're a little bit easier to read. I'm going to look for my rise over my run. So I see that my rise is up 2 and my run is over 1. So my rise is 2, run is 1. Okay, and then I'm going to go ahead and simplify that fraction, which is going to be equal to 2. And just one more in case you chose different points. I'm going to do one more quick example with 2 different points. So now I'm going to pick, just for funsies, I'm going to use this point down here at -2, -3, and this point at the y-intercept, which is 0, 2. So let's just double check to see if my slope is correct. So my rise in this case would be up 1, 2, 3, 4. My run would be 2. So I would have 4 divided by 2. And we see if I simplify that fraction, 4 divided by 2 still gets me to a reduced slope of 2. So no matter which 2 points you choose, you should come to that final conclusion of 2.